Today, in ET subject, emerging trends in electronics, we will study the architecture of data routes. We have studied IoT, cloud, edge gateway. So today we will study the architecture of data routes. So IoT architecture, there are three basic layers in that IoT architecture. One is client side layer, that is IoT device layer. Operator on server side means IoT gateway layer, and a pathway for connecting client and operator means communication medium, that is IoT platform layer. So three layers are there in IoT architecture: client side, server side, and connecting client and operator side. The addressing needs of all these layers is crucial on all the stages of IoT architecture. Being the basis of feasibility criteria, this consistency makes the result designed really work. In addition, the fundamental features of sustainable IoT architecture include functionality, scalability, availability, maintainability. Without addressing these conditions, the result of IoT architecture is a failure. Therefore, all above mentioned requirements are addressed in 4 stages of IoT architecture. So the 3 IoT architecture layer that we have mentioned above, that is client side, server side, and a pathway. These 3 architecture is again distributed in 4 stages of architecture. 3 layers are distributed in 4 stages. The 4 stages are the sensors and actuators, internet gateway and data acquisition system, edge IT, and data center and cloud. So that 3 layers is divided in 4 stages. So client side, obviously sensor and actuator. The operator side is nothing but the data center and cloud, and the pathway is divided in 2 stages, that is internet gateway and edge IT. So these stages are elaborated here. The stage 1, that is wireless sensors and actuators. The outstanding features about sensor is their ability to convert information obtained in the outer world into the data for analysis. In other words, it's important to start with the inclusion of sensors in 4 stages of IoT architecture framework to get information in an appearance that could be actually processed. Sensor काय काम करतं? जो त्याच्याकडे डेटा आहे तो सुटेबल फॉर्म मध्ये कन्वर्ट करतो जेणेकरून तो अनालाइज करू शकू. करेक्ट? त्याच्यामुळे सेन्सर हे त्या 4 स्टेजेस जे आहे आयओटीचे त्याच्यामध्ये फ्रेमवर्क मध्ये आपण इन्क्लूड केलेला आहे की तो अशा फॉर्मॅट मध्ये डेटा कन्वर्ट करतो किंवा अशा अपीअरन्स मध्ये कन्वर्ट करतो की जो ऍक्च्युअली प्रोसेस करू शकतो. अँड ऍक्च्युएटर्स, these devices are able to intervene the physical reality. For example, they can switch off the light, adjust the temperature in a room. Because of this, sensing and actuating stage covers and adjusts everything needed in the physical world to gain the necessity insights for further analysis. Means whatever data is sensed, that is analyzed, that is processed, the results are then generated. These results are stored in the cloud as well as they are given to the actuators, which changes the physical environment. So in this way, actually IoT works. So stage number 2 is sensor data aggregation systems and analog to digital data conversion. So stage 2, what it does, whatever number of sensors are there to the single IoT system is connected, all the sensor data is collected together, that data is aggregated, means it is combined together. Whatever sensors are digital sensor, there is no requirement of A to D conversion. So direct that data is in the suitable format itself, so that data is directly passed to the cloud through the gateway. And the sensors which gives output in analog form, first of all using digital modulators or analog to digital converter, the data is converted to digital form and then it is given to the data acquisition system so that data can be logged into the cloud. Correct? So later connect to the sensor network and aggregate output, while internet gateways work through Wi-Fi and wired LAN and perform further processing. The vital importance of this stage is to process enormous amount of information collected on previous stage and squeeze it to the optimal size for the further analysis. Besides, the necessary conversion in terms of timing and structure happens here. In short, what stage 2 does? The stage 2 makes both data, means sensors data, is converted in digitized and aggregated manner. डिजिटल डेटा असेल तर ठीक आहे, तो ऑलरेडी प्रोसेसेबल फॉर्मॅटमध्ये आहे. अॅनालॉग डेटा असेल तो पहिले डिजिटल फॉर्मॅटमध्ये कन्वर्ट करून सर्व डेटा हा ऍग्रिगेट केला जातो, पॅकेट्सच्या फॉर्मॅटमध्ये क्रिएट केला जातो आणि तो डेटा गेटवे थ्रू हा इंटरनेट आणि क्लाउडला पास ऑन केला जातो सेन्सर स्टेज 2 थ्रू. Okay, so we'll go through this diagram later on. First of all, we'll go through the theoretical part. Stage 3 is edge IT system. In particular, edge IT system performs enhanced analytics and pre-processing. The function pre-processing is performed by edge IT. For example, it refers to machine learning and visualization technology. At the same time, some additional processing may happen here prior to the stage of entering the data center. Likewise, Stage 3 is closely linked to the previous phases in the building of architecture of IoT. Because of this, location of edge IT system is close to one where sensors and actuators are located, creating a wiring closet. At the same time, residing in remote offices is also possible. So what it does, whatever data is coming from the sensors, that data is analyzed, correct, and it is pre-processed. Before sending it to cloud, the data is pre-processed. Means to reduce the overhead that is going to occur on your pathway or cloud, some pre-processing of the data is required. So that pre-processing is done in stage 3, that is edge IT. Stage 4 is analysis, management, and storage of data. The main process on the last stage of IoT architecture happens in data center or cloud, precisely telling that it enables in-depth processing along with a follow-up provision for feedback. Here, the skills of both IT and OT professionals are needed. In other words, the phase already includes the analytical skills of the highest rank, both in digital and human world. Therefore, the data from other sources may be included here to ensure an in-depth analysis. After meeting all the quality standards and requirements, information is brought back to the physical world, but in a processed and precisely analyzed form. So in stage number 4, actually whatever data is coming from the gateways, that data is processed properly. Okay, it is analyzed and management is done on that data, that where to store it, where to pass it on, correct. And when data is processed, it is physically stored on your server or your memory disk, etc. And that you call it as a cloud. Cloud is nothing but what? Some storage rooms are there which are connected to the internet. So there you store that data. And stage 5 of IoT architecture, there are actually 4 stages only, but this 5th stage is added here. That in fact there is an option to extend the process of building a sustainable IoT architecture by including an extra stage in it. It refers to initiating a user's control over the structure. If only one user results doesn't include full automation, the main tasks here are visualization and management. After including stage number 5, the system turns into a circle where a user sends command to the sensors and actuators to perform some action. Means suppose that sensors are collecting data from the physical environment, data is stored into the cloud, the predefined program will be there, according to that actuators will take the action. But you can include stage number 5, that human can intervene into the system. He can send commands to the sensors and actuators for performing some actions. So stage number 5 is optional. It is not compulsory every time. Okay. So these are the 4 stages, and 5th extra stage of IoT is there. So if you go through this diagram, you will find that these are the things, correct, the machineries. So stage 1, these physical parameters are analyzed and senses through the sensors, and whatever command is received from stage number 4, the stages are that commands are received from the clouds and actuators perform action on it. So stage 2, the data acquisition system, means data is collected together, some computers and gateways are there, correct, and then this edge gateway pre-processes the data, and through Wi-Fi network it is connected to the cloud, and cloud then store this data coming from edge gateway or edge IT. The data is analyzed, managed, and stored. It is archived, actually, you know meaning of archiving. So that data is archived over there. If some command is taken, that command is transferred through edge IT, internet gateway, to the actuators. So in this way, this IoT architecture works. So stage 1, actual physical sensors, actuators are there. Stage 2, data acquisition system. Different sensors generate data. That data is combined together in the form of packets. That packets are sent to the cloud through Edge IT. Edge IT pre-processing of data is done. And what cloud does? Cloud analyze that data, and that data is stored into the server or memories. So in this way, this IoT architecture works. So there are different data routing is there. At the time of discussion of unit objectives, we have studied the different types of data routing techniques there. Data routing means what? From sensor to cloud and cloud to architecture, how the data is managed or how paths are created. So we are going to study it one by one. First type of data routing is sensor to cloud. Okay. In the world of industrial automation, applying human machine interface HMI to control and monitor machines, processes, and even smart buildings has been a common practice for many years. These industrial HMIs, sometimes called operator interface terminals, are good at what they do, but have traditional requirements, significant engineering efforts for development, deployment, and maintenance. They also typically include many proprietary elements and require ongoing expenditures for software and licensing. The automation engineers are increasingly taking advantages of various smart systems in the field, including IoT devices. These devices have lots of useful data to offer and frequently need monitoring, and are sometimes used as inputs to the real-time control system. But the traditional method of connecting these remote devices through standard industrial systems are difficult and costly. However, the next generation of HMI and SCADA hardware and software addresses these and other challenges. By using the latest commercial and open source technology, these products can make users free to connect with smart system, getting data transforming into a actionable information and visualizing it when and where user want. So first type of data routing that we're going to study is sensor to PLC, PLC to SCADA, and SCADA to the cloud data route. So in this way, the data is transferred from sensor to the cloud. So how it transmits data? So we'll see that. The classic approach involves several steps and linkage to make edge data available up to the cloud. These connections are difficult to configure initially, but they are also challenging to maintain over time, with required maintenance beginning at the periphery and processing inward. So in PLC SCADA gateway, the first field device is likely wired and networked to a local programmable logic controller. Since this is often nearest programmable system to the edge component, the PLC requires some device-specific communication driver or instruction to obtain the data, which may involve choosing the desired point and mapping them in a spreadsheet-like format. So whatever data is collected from number of sensors through PLC, so PLC may require some drivers. That data is coming from different sensors, it's combined together, and it is inserted in a spreadsheet-like format. So Excel sheet is generated. Then next, PLC data is networked up to the PLC-based HMI or SCADA system, with either approach requiring configuration of data tags, drivers, and polling rate assignments. So this collected data, PLC transmit this data to the cloud through PC-based HMI or SCADA system. Okay. In turn, HMI or SCADA needs additional configuration or programming steps to transport the data into a cloud-based database where it can be made more widely available. So sensors captures the data, converts into digital form. This digital form data is recorded in the PLC in the form of Excel sheet or spreadsheet like of structure. Then using human machine interface or using SCADA supervisory system, the data is transmitted to the cloud through the gateways. Okay, so in this way, this sensor PLC SCADA cloud data route works. So what are the major drawbacks of this system? Typically, PLC and communication drivers may be proprietary. Correct? Means there is a need of purchasing that rights for using that. Requires costly configuration, software, and licenses. You know that there are very few software companies which works on PLC software, SCADA software. So whatever softwares are there, these softwares are very costly. Even with right hardware and software in hand, designers required specialized knowledge of devices, programming, and networking. Correct? You know that PLC operators must have some specialized knowledge. So the specialized operators are required for operating this data routing. The last networking link from the project side to the cloud demands dedicated attention to go through the firewalls and maintain security. So the security and firewall maintenance is a cumbersome task. It is a somewhat difficult task in case of PLC SCADA system. So next type of data route is used. That data routing is sensor server cloud data routing. So in sensor server data routing, the device to device means direct contact between two smart objects when they share information instantaneously without intermediary. For example, industrial robot and sensors are connected to one another directly to coordinate their actions and perform the assembly of components more efficiently. This type of connection is not very common yet because most devices are not able to handle such processes like this. Suppose one gateway will be there. These are the devices, different devices. Using the gateways, the data is transmitted to data system or directly to the server using some wired or wireless network, or sometimes direct to vehicle. Suppose some two robots are there, that two robots directly can communicate with each other, using some wired or wireless technology, and that synchronization may happen between two machines. Okay, so this is one kind of data routing is possible. That data routing is device to device data routing. And another type of data routing is device to gateway. So whatever you are studying over here, see this is one camera, it is collecting data. That data is collected, given to the gateway, then gateway will transmit that data to the data systems. It is stored on the server or cloud. Based on that, some actions or commands are generated. That commands are given to gateway. Gateway will give command to this robotic hand, and then according to that, robotic hand will move its actuators, and some picking up action will be taken place. So where the component is at present, and that robotic arm will go there, and it will pick up that device or that thing. Okay, so this is device to gateway data routing. And device to device gateway routing means camera and robot will be in coordination or synchronization with each other. Data is not given to gateway. Direct communication between device to device is taking place, and then work is done. But in that condition, the data system does not keep the log of the thing that are happening. Okay, so this is your device to device and device to gateway data routing. Okay. The third is gateway to data system. The data transmission from a gateway to appropriate data system. To determine what protocol to use, you should analyze the data traffic. Correct? Means frequency of burstiness and congestions, security requirements, and how many parallel connections are needed. And between data system. Okay. So information transfer within data centers or clouds. Protocol for this type of connection should be easy to deploy and integrate with existing apps, have high level availability, capacity, and reliable disaster recovery. So how this sensor server cloud data routing happens? Sometimes device to device communication may directly takes place. Device to gateway communication takes place. Then this gateway to data system communication takes place. And if two different data systems are there, between data system communication may takes place. Correct? So in this type of communication, data routing takes place in this way. Device to device directly communication होऊ शकतं, device to gateway communication होतं, gateway to data system communication होतं, आणि दोन सबसिस्टीम डेटा सिस्टीम मध्ये पण कम्युनिकेशन होऊ शकतं. आणि त्या गेटवे टू डेटा सिस्टीम आणि डेटा सिस्टीम टू डेटा सिस्टीम कम्युनिकेशन साठी काही स्टँडर्ड प्रोटोकॉल्स पण डेव्हलप केलेले असतात. ओके, सो दिस इज युअर सेन्सर सर्व्हर क्लाउड डेटा राउटिंग. थर्ड इज सेन्सर टू एज गेटवे टू क्लाउड गेटवे. ओके, सेन्सर टू एज gateway to cloud architecture. Okay, see this. These are the number of devices. These devices transmits data to the gateway. This gateway is a local gateway. Okay, so data from sensors are given to gateway. From gateway, that the data is given to IoT cloud. Okay, IoT cloud. Then from IoT cloud, the data will be sent to the applications. That applications may be your home appliances, maybe your machinery. Based on the judgment, some commands will be generated. That commands will be given to IoT cloud. From IoT cloud, the data is given to the gateway, and from gateway, the commands are given to the actuators. Actuators, I'm saying. So data is going to the cloud from sensor, and from cloud through gateway to the actuators. So this is the most common architecture that we see. जे आपण या सब्जेक्ट मध्ये आधी पण स्टडी केलंय आणि आता पण आपण बघतोय. थर्ड टाइप ऑफ डेटा राउटिंग. पहिली आपण पीएलसी बेस्ड, दुसरी बघितली आपण सर्व्हर बेस्ड, आणि तिसरी बघतोय आता आपण गेटवे आणि क्लाउड बेस्ड. ओके, सो देर आर डिव्हाइसेस, गेटवेज, and in above case there were what? Servers. There were servers. So this is important thing. Okay, so the three types of you can say data routing techniques are there. Okay, first is sensor, PLC, SCADA, cloud based data routing. Second is sensor, server, cloud data routing. Third is sensor, edge gateway, cloud data routing. Means between sensor and cloud, how the data routing takes place, that we are seen. First is PLC based, and which was very traditional type of data routing. But in that case, what were the main drawback? The operators must be skillful operator. The configuration required for PLC are costly. Correct? Very few companies are there which generate that drivers. So there were some disadvantages. Correct? Then sensor, server data routing we have seen. That is also a good type of data routing. So in that data routing, what we have seen, that device to device communication can happen, device to gateway communication can happen, gateway to cloud communication can happen. Cloud means data servers or database, and between two database communication can happen. Okay, but here in sensor edge gateway and cloud architecture, sensor to edge gateway to cloud gateway, and then from cloud gateway to the application. Applications, maybe your mobile phone, from smartphone you can operate this sensors and actuators. Okay, so this is the most modern type of architecture of data routing. So mostly this sensor, edge gateway, cloud architecture is used. Is there any doubt? Is there any doubt in three type of data routing technique? Is there any doubt?
Sir, third one.
Third, sensor collects the data. That data is given to the edge gateway. Edge gateway pre-processing करतो डेटावर, तो डेटा क्लाउडला जाणार. क्लाउड सर्व डेटा जो काही कलेक्ट करणार आहे, तो वेगवेगळ्या ऍप्लिकेशनवर तुम्हाला दाखवू शकतो. म्हणजे मॉनिटरवर दाखवू शकतो, मोबाईल ऍप्लिकेशनवर दाखवू शकतो, एखाद्या मशिनरीवर दाखवू शकतो. ज्या काही हे जे ऍप्लिकेशन्स आहेत, ते जे काही कमांड जनरेट करतील, ते कमांड्स क्लाउडला जातील, क्लाउडवरून एज गेटवेला जातील, एज गेटवेवरून ऍक्च्युएटर्सला जातील. म्हणजे सेन्सर आणि ऍक्च्युएटर काय काम करतं, प्रत्येक ठिकाणी काम सेम करतंय. कुठलं या डेटा राउटिंग घ्या. फक्त आपण काय स्टडी केलं की डेटा जो आहे तो सेन्सर टू क्लाउड आणि क्लाउड टू सेन्सर कशा पद्धतीने जाऊ शकतो. तर पहिल्या केसमध्ये पीएलसी आणि स्कॅडा टेक्निक थ्रू जाऊ शकतो, दुसऱ्या याच्यामध्ये सर्व्हर डेटाबेस टेक्निक थ्रू जाऊ शकतो, आणि तिसऱ्या याच्यामध्ये एज गेटवे टेक्निक थ्रू जाऊ शकतो. पण एज गेटवे ही मॉडर्न टाइप ऑफ टेक्निक आहे, ज्याच्यामध्ये सिक्युरिटी पण जास्त पद्धतीने असू शकते आणि डेटा राउटिंग पण खूप चांगल्या पद्धतीने होऊ शकते. आता झालं क्लिअर?
Yes, sir.
Okay. Now we'll see the IoT application. So first, IoT application that it can be used in automotive sector. बऱ्याच वेळेस आपण बघतो की ड्रायव्हरलेस कार, अगोदर ज्या वेळेस टीव्हीवर न्यूज मध्ये दाखवायचे ड्रायव्हरलेस कार, तर खूप मोठी गोष्ट वाटायची. So this is possible because of IoT only. The idea of IoT in automotive sector was being seen as a futuristic theoretical concept And today we are already seeing possibilities of connected cars, driverless cars, and applications of IoT in the car ecosystem. This includes smart parking, environment, supply chain, transport governing body. It is also used in related automotive segments such as car service applications, vehicle communications, IoT in intelligent transportation, IoT-based supply chain management in automotive industry, and new generation cars. आपण बऱ्याच वेळेस कारचे इंटरनल एन्व्हायरमेंट मॉनिटर करण्यासाठी आयओटीचा यूज करू शकतो, किंवा सप्लाय चेन मध्ये आपण यूज करू शकतो. स्मार्ट पार्किंग म्हणजे कुठला पार्किंग स्लॉट बुक झालेला आहे की नाही, कुठे पार्किंग आहे ते ऍट द एंट्रन्स ऑफ पार्किंग तुम्ही ते डिस्प्ले करू शकता. बरोबर. सप्लाय चेन मॅनेजमेंट मध्ये तुम्ही ते यूज करू शकतात, किंवा न्यू जनरेशन कार मध्ये आपण डायरेक्टली ड्रायव्हरलेस कार म्हणून या ऍप्लिकेशन मध्ये पण आयओटीचा वापर करू शकतो. सो आयओटी इज अ हार्ट ऑफ दिस डिजिटल ट्रान्सपोर्टेशन इन ऑटो सेक्टर. It connects people, machines, vehicles, auto parts, services to streamline flow of data, enable data time decisions, and improve automotive experiences. Leading automotive manufacturers, suppliers, and dealers have started investing heavily in IoT and are gaining returns in the form of efficient inventory management, real-time promotions that grow sales, reduced operational expenses, and increase in revenue. तुम्ही बऱ्याच वेळेस टीव्हीच्या ऍड मध्ये म्हणजे आपण ऍडव्हर्टाइजमेंट नाही करत, एमजी हेक्टर कारची तुम्ही ऍडव्हर्टाइजमेंट बघितलेली असेल, तर हे खूप चांगलं एक्झाम्पल आहे आयओटी बेस्ड सिस्टीमचं. तुमची कार आणि तुमचा सेलफोन हे थ्रू क्लाउड गेटवे कनेक्टेड आहे. तुम्ही इकडून ज्या कमांड देतात त्या तिकडे कारमध्ये ऍक्च्युएटर्सला त्या कमांड दिल्या जातात, किंवा कारचे जे काही सेन्सर्स आहे तो डेटा कलेक्ट करून क्लाउडला जातोय, तो तुमच्या सेलफोनवर तुम्ही बघू शकता. एसी आधीच चालू करून ठेवणं, कारची विंडो डाऊन करणं, कारची हेल्थ चेकअप करणं, त्यानंतर पार्किंग, ऑटो पार्किंग करणं, हे जे काही तुम्ही खूप मॉडर्न कार्स मध्ये बघत आहात, तर हे एक परफेक्ट एक्झाम्पल आहे आयओटी इन ऑटोमोटिव्ह सेक्टर. करेक्ट. इफ यू टेक वन मोर एक्झाम्पल, ट्रॅफिक कंट्रोल सिस्टम्स कॅन प्रोव्हाइड रिअल टाइम डेटा कलेक्शन फ्रॉम कनेक्टेड कार्स टू अवॉइड ट्रॅफिक जॅम्स अँड ऍक्सिडेंट्स. सपोज एखादा प्रत्येक कार जर आयओटी एनेबल्ड असेल, तर एका कारमध्ये जर एक आयओटीचं जीपीएस सिस्टीम बसवलेली असेल, तर एका लेन मध्ये किती कार्स आहे त्याच्यावरून तुम्ही तुमच्या सिग्नलचा टायमिंग चेंज करू शकता. सो दिस इज वन मोर परफेक्ट एक्झाम्पल ऑफ आयओटी, जे की आपण म्हणतो की आर्टिफिशियल इंटेलिजन्सने आपण चेक करू शकतो की किती कार्स एका लाईन मध्ये आहेत, ते आयओटीने पण चेक करू शकतो. सो कसं इम्प्लिमेंट करू शकतो आयओटी, तर कनेक्टेड कार एकमेकांना कनेक्ट कसे होऊ शकतात, त्याच्यानंतर कार सर्व्हिस ऍप्लिकेशन मध्ये पण तुम्ही कनेक्ट करू शकता. व्हेकल स्मार्ट फोन इंटिग्रेशन तुम्ही आयओटी यूज करू शकता. ड्रायव्हिंग इन्साइट्स किंवा अनालिटिक्स मध्ये चेक करू शकता. ऑनबोर्ड डायग्नोस्टिक फॉर प्रेडिक्टिव्ह मेंटेनन्स मध्ये तुम्ही यूज करू शकता. सेफ्टीसाठी यूज करू शकता. जिओ फेन्सिंग आणि स्पीड मॉनिटरिंग साठी आयओटी यूज करू शकता. किंवा लॉ म्हणजे तुम्ही तुमची गाडी कुठे आहे आता चोरीला गेली ट्रॅक करण्यासाठी यूज करू शकता, किंवा बायोमेट्रिक साठी यूज करू शकता. व्हेकल कम्युनिकेशन साठी यूज करतात. सो देर आर लॉट ऑफ ऍप्लिकेशन ऑफ आयओटी इन युअर व्हेकल सेक्टर. सो दिस वॉज द मेन पार्ट ऑफ आवर